Hey guys, so this problem is one that a lot of students have had trouble with from the homework, Applied Dimensional Analysis, and this is question number 3, and so I thought I would do a little video to show you guys how to work this. So the question says, the density of gasoline is 0.68 grams per centimeter cubed. How large a container in liters would you need to hold 7.2 kilograms of the gasoline? So what we're going to do is work this out using the method that we used in our interactive notebook. So if you want to follow along with that, go ahead and pull out your interactive notebook. And remember, there was a 7-step process. So I'm going to work this through step by step. The first step of the process is to write out all of your known conversion factors. So there's actually 2 conversion factors used in the problem that it gives you, and I haven't written those down, but one of them is that 1 kilogram is equal to 1,000 grams, and another one is that 1,000 milliliters is equal to 1 liter. You'll also notice, though, that for units of volume here we have milliliters and liters, but the density in the problem uses centimeters cubed. So we will need to remember that 1 centimeter cubed is equal to 1 milliliter. And then the last conversion factor that you need to be familiar with is actually the density. And so that's a little bit weird, but the density here we can use as a conversion factor to convert between mass and volume. So when we write out density as a conversion factor, we're going to write, in this case, 0.68 grams over 1 centimeter cubed. And that means that for every 0.68 grams of gasoline, we're going to occupy a volume of 1 centimeter cubed. That's the density, but it also is a possible conversion factor. Step 2. So in step 2, we're going to identify what we are converting from and what we are converting to. So we are converting to how large a container in liters we would need. Okay, so we're going to be converting to volume in liters. And we are doing that based on the mass of the gasoline. So how large a container in liters would we need to hold 7.2 kilograms of gasoline? So that's what we are converting from, is 7.2 kilograms of gasoline. All right, on to step 3. In step 3, we're going to start with the given information that we are converting from. In this case, 7.2 kilograms of gasoline. For step 4, we're going to add conversion factors to this until we get to our answer. So we again start with the 7.2 kilograms of gasoline. And there's nothing under that, right? Our next conversion factor we know is going to have kilograms in it because that's what's on top here. So we look up at our list of known conversion factors and we'll find that 1 kilogram is equal to 1,000 grams. So we're going to put 1 kilogram, 1,000 grams. And that allows us to cancel kilograms with kilograms. Now we have grams on top. That still isn't what we're looking for. So we're going to do the next conversion factor that uses grams, and that's the density. So we know that for every 0.68 grams, we have a volume of 1 centimeter cubed. So next, we'll have 0.68 grams, 1 centimeter cubed. Now we can cancel grams with grams. That uses this conversion factor. Now we have centimeters cubed on top. That still isn't volume in liters, so we're going to convert again. This time, we'll need centimeters cubed, so we know that 1 centimeter cubed is equal to 1 milliliter. That still isn't volume in liters, so we're going to have to convert at least one more time. We've got milliliters on top now, so our next conversion factor will need to have milliliters on bottom. That's 1,000 milliliters is equal to 1 liter. Now we do have liters as our remaining unit. Step 5 asks us to check our unit to make sure that it matches the unit of what we're trying to convert to. And that's what we just did. We're going to end with liters, and liters is what we're looking for, so we're done there. Step 6. In step 6, we're going to use our calculator to multiply everything on the top and everything on the bottom. So on the top we have 7.2 times 1,000 times 1 times 1 times 1 liters. So that's going to give us 7,200 liters on top. On the bottom we multiply 1 times 0.68 times 1 times 1,000, and that's going to give us 680, and there's no unit on the bottom. For step 7, the final step, we're going to take the top and divide it by the bottom, and that's going to give us 10.5882359 liters. But of course we know there's another half to step 7, and that's to round for significant figures. So we're going to look back at the problem at our original measured values. That's going to be the density and the mass of the gasoline. The density, 0.68, has 2 significant figures, and the mass of the gasoline, 7.2 kilograms, also has 2 significant figures. So 2 significant figures is what we're going to round our answer to. So down on the bottom we'll count 1, 2, and then we'll use this next digit of 5 for rounding. Since it's 5, we're going to round the previous number up, and this is going to round to 11 liters. And that's your answer.